And here we are now up at the Laver Dam storage facility. This is the main flood protection measure that we are installing at this moment. The dam that you can see behind me is over 400 metres long, 9 metres high to its crest, and over 90 metres thick at its base, and is shaped in a triangular section so that we can allow for rainwater to dissipate off it into the river. What this dam does is it holds back peak flows of when the river is in flood. As you can see behind me, we do have a large temporary work office setup. This has been designed from a sustainable point of view. We have used modern technologies, we've used modern techniques and construction materials to greatly reduce the CO2 footprint of the structure. We believe from records that we have saved over 40% of potential CO2 footprint for this office setup during our 15 months on site. That is a considerable saving of over 400 tonnes of CO2. Obviously, with this project being in the middle of a rural environment and of a completely virgin site, we've had to work very closely with local landowners and suppliers to create access routes and access haul roads for the works. A further point of the way that Interserve constructed the works is below where I stand now is Ripon's only supply pipeline for fresh water, fresh drinking water. And as you can see, we've fenced off an easement area of 10 metres to ensure that no damage can be done to this pipeline by our operations. This is a badger mesh, and we install this mesh underneath the topsoil for the dam so that we can stop any badgers deciding to make this their new des res. The issue for that, the reason behind this is the fact that once a badger is in situ within a structure, it is very difficult for you to get rid of them. They have an awful lot of legislative support behind them, and it does take an awful lot of time and money to remove a badger from his set. So to overcome that, we've thought about this up front, and we've come up with this as a design solution, this very heavy duty gauge mesh that we place into the dam to stop them burrowing in. So here we are down by the river inlet channel works. Next to me is the River Laver. Now this is the main river that we actually control as part of the flood defence works. The river here has been diverted from its original course through a twin box culvert system which goes all the way underneath the dam and allows for direct control of the river flow. What you will see over by the culverts there is some metal frames where orifice plates will be fixed when the dam is completed to restrict the flow of the river to a 1 in 10 year event, or as I often say, is a 10% chance per year of the flow achieving that value. At the crest of the dam there is some machinery. When the dam is full and in its maximum storage capacity, the water will be overtopping the dam at that point. As you can see, that is approximately 11 metres above the position I'm stood. And now here we are down at the outlet of the culverts. As you can see, we're on the downstream side of the dam. As is always with our construction, we've tried to build this in the most sustainable fashion that we can. We've utilised recycled stone from the borrow pit. We've also utilised gabion basket designs rather than concrete because the CO2 footprint is greatly reduced. But what you can see, and what is interesting at this point, on the far wall there is some black structures, and those are flap valves, and they are to help the back of wall drainage. And because they've been in for a winter, the power of the water that has come through this culvert has actually ripped the flap off the front. So we've now got to go away, and we've come up with a new design where the non-return valve will be in situ to the wall, and we have to core the wall out to achieve that.